Hi everyone, my name is Esme.
And my name is Jeremy.
For our project, we chose to focus on modeling the gyro turning of my 3-pound BattleBot called VLOOKUP. Gyro turning is a relatively common phenomenon in smaller weight class combat robots, and you can see some examples in the videos that are shown here. The weapon spin extremely fast, resulting in a high angular momentum. When the robot begins to turn, the weapon's angular momentum begins to change rapidly, and a moment is reacted against the axle of the weapon. This causes one wheel of the robot to lift, which can make maneuvering much more difficult. Because these robots are so small, these designs are often over-constrained, and we were interested in modeling the robot after lifting, assuming that it would be difficult for builders to design their robot to never lift off the ground, and instead wanted to focus on understanding the severity of the gyro turning in their robot design. As a result, we modeled the robot as a compound pendulum about the planted wheel, and the weapon is a gyroscope. Equal and opposite reaction forces act on the two bodies, and the two bodies share position, velocity, and acceleration. With these, we derived equations of motion that allowed us to model the position of the center of mass of the robot and feed that into an easy-to-understand application for robot designers to use.
So here's the app we developed. It's pre-populated with all of the parameters that come from VLOOKUP, but you can obviously change these with whichever values you would like. So we're going to start by setting our simulation granularity, and that just determines how many iterations we sweep through as far as the rotation speed, and then we can hit run model. And so what we're going to see here is we have a maximum turning throttle, and that is a percentage of the bot's rotation speed, and that's also graphed over here for the maximum lift angle based on speed. So that is the last value before anything rises above about 0.1 degree. And then up here we can see the maximum for the maximum rotating speed, what the bot's path looks like as it rotates about 90 degrees. And so if we were to run the model again, but say we, let's decrease the maximum weapon speed. So instead of 16,000 radians per second, let's move it down to about, call it 1150 or so, or sorry, 1150. And we can run the model again. We'll see that the angle at which the speed at which it starts increasing angle gets pushed a lot further along the rotation speed, and that actual path is much more flat with less height.